Welcome to lesson 12 of this Arduino C++ course, and today, as the title says, we're going to be looking at stepper motors. And the stepper motor that I'm going to be looking at is the 28BYJ-48 with the ULN2003 stepper motor driver. And these are the type of stepper motors that come in most starter kits. So as you can see from this photo, these are the products that we're going to be looking at. Obviously, this is the stepper motor and this is the driver board. As you can see, there are 4 pins here. I think it is IN1 to IN4. These are going to connect to the digital pins, and then there is the 5-volt input here. There is an optional 12-volt, but I will be using the 5-volt input today. Now, today's tutorial will be the first of 1, if not 2 lessons on using these starter motors. As you can see from the breadboard, I've actually got 2 motors that have been set out because I want to show you how to combine multiple motors and also to write the code in such a way that other things can happen at the same time. So you can see I've got an LED that is blinking here at a 1-second interval, and this is purely to show that this is non-blocking code. I've then got these 2 buttons, and as you can see, one stepper motor is moving quickly, the other is moving slowly. If I click the other button, they will start to move in the opposite direction. So the goal here is not only to control multiple stepper motors, but to be able to control them with independent inputs running at different speeds and even in different directions at the same time. So I want to teach you how to integrate these into a project rather than just turning them clockwise and then anti-clockwise. So as always, if you go to the Digital Town website, to the lessons page, just scroll down and you'll eventually come down to lesson 12. There is the code to download from today's lessons and obviously the circuit diagram. Click on this for the larger version, as you can see. So let's work through the circuit diagram. Some of it will be very familiar from previous lessons. So down here on the right hand side, there is a red LED connected through a 330 ohm resistor, and that is going to pin 12. And during this project, that is literally just going to flash on and off at 1-second intervals, just to show that none of the code is blocking. On the left hand side, I have 2 buttons. Both of mine are connected through 4.5k pull down resistors. So that means that goes from the one leg of the button to ground, while the other leg of the button goes to the 5 volts. And obviously there is this connection here between the resistor and the pin that is going to pin 2, and on the other switch to pin 3. You can obviously use a 10k resistor if you don't have any 4.5ks. It'll work just as well. Now for this project, I will be using the breadboard power supply. That in itself requires a 7 to 12 volt DC supply. Make sure you've got the little settings to 5 volts. The reason for using the breadboard power supply is that 2 stepper motors is drawing too much power for an Arduino. An Arduino is not a power station. It has a very limited power output, and really things like motors, servos, stepper motors, the Arduino is not designed to power those sort of components. Now here you have the 2 ULN2003 stepper motor driver boards. I have got the 5 volt supplies connected. Obviously it's a 5 volt and a ground. Speaking of grounds, you need a ground that connects from the Arduino to the breadboard. Although the power is coming from the DC power supply, the breadboard power supply, there does need to be a ground connection back to the Arduino. Then I've got an orange, a yellow, a green and a blue, and for the 1 stepper motor they are connected to pins 4, 5, 6 and 7, and the other stepper motor is connected to pins 8, 9, 10 and 11. Now obviously not everybody has got two stepper motors. The reason I'm including two is that I wanted to show you how you can use multiple stepper motors, and in this project the code that could be used for two could be used for 3, 4, 5 or more. You can just continue. However, if you've only got one stepper motor, I would suggest you do the stepper motor on the left, which is pins 4, 5, 6 and 7, and you'll see the connections within the sketch so that you know which pins connect to which. So moving over to the Arduino IDE, and again, if you are new and you're wondering why my IDE looks different to yours, I am using in the preferences the dark theme because it's better for my eyes. Okay, going through the sketch, I've called it stepper 1, and I am connecting two buttons, one LED and two stepper motors, both being connected through two different ULN2003 drivers. The pins are listed here: left button pin 2, right button pin 3, and then pin 4 goes to IN4, 5 to IN3, 6 to IN2, 7 to IN1. These are labeled on the 2003 driver board, so you'll be able to find them easily. Then the other stepper motor, if you do have the second stepper motor to play with, connect 8 to IN4, 9 to IN3, 10 to IN2, 11 to IN1, and then finally I've got my red LED on pin 12. Now normally when people use stepper motors in a kit for the first time, they go up to File, Examples. Obviously you won't have as many libraries as I have on my IDE, but if you keep going down you will find the built-in stepper motor library and go to Stepper 1 Revolution. And when this sketch comes up, what it basically does is you include the stepper motor library, you put in the steps per revolution, which for this particular type of stepper motor is 200. You put in the pins that you are connecting your stepper motor through. Obviously my second stepper motor is connected in that way, and then you set a speed, and in this case they've started the serial monitor. And then what they do is they move the stepper motor a number of steps in one direction. So basically they do one revolution, 200 steps. They then put a delay in of half a second, and then they move the stepper motor back the other way. Now, when you are writing non-blocking code, delay is an absolute pain, because it will wreck your main loop. So I will not be using this example in the tutorial today. However, some of the code from this will be used in this first sketch. Now, I'm not going to go into the stepper motor example in any detail because, being blunt, it's not a very good sketch, and I'm going to show you why it's not a good sketch. So I've included the stepper motor library, steps per revolution. I've created a left stepper and a right stepper object. I've got my left button pin, right button pin, the LED. I've started the serial monitor, and I've just printed out stepper 1. I've set the pin modes for the left button and the right button as inputs, and then I've set the pin mode for the red LED. Once again, I've set the stepper motor speeds as in the example, and then what I've done is I've quickly flashed the red LED on and then off with a half a second delay. Now, because it's in the setup, that is not going to cause a problem. Then what I've done is I have set the left stepper to move 1000 steps and the right stepper to also move 1000 steps. And I want you to pay particular attention to these two lines because they are very, very important. Now, a couple of things just to point out. In the sample sketch, they only move the stepper 200 steps, which is one rotation. You'll notice I have chosen to move the stepper 1000 steps, which is 5 rotations. And the reason is obviously 5 rotations will take a period of time, and it helps to demonstrate an issue with the built-in stepper motor library. So what I'm going to try and do now is run the project while we look at the lines of code in operation. So I'm just going to set the cursor next to the red LED because that's where we're going to start. Let's press the reset button. LED came on for half a second. Now notice this is now driving the left stepper motor, then we get the right stepper motor. Now there is a problem. Did you notice, let's do it again, you'll notice that the left stepper motor moved, and then when it finished moving, the right stepper motor started. Let's do that again. Left stepper motor, right stepper motor. Now you might ask yourself, what was wrong with that? Let's look at the code again, and hopefully you'll see the issue. I sent a command that I wanted the left stepper to move 1000 steps, but I immediately sent a command to the right stepper to move 1000 steps. So my goal was that this stepper motor would start moving 1000 steps while the other stepper motor also started moving 1000 steps. What you'll have noticed is the left stepper motor moved. When it had finished moving, the right hand stepper motor started to move. Now, if you want to build a project with multiple stepper motors running at the same time and moving in different directions, those two lines of code, if you like, should start to set off some alarm bells. And what I'm now going to do is take you down to the main loop to, shall we say, ring some more alarms. So as we look at the main loop, what I've done is I am doing a digital read on the left button, and then I'm doing a digital read on the right button. And then all I'm doing is outputting to the serial monitor the state of both buttons. So let's just run that code so you can see what comes up. So looking at the serial monitor, you can see 2 zeros. If I press the 1 button, I get a 1, press the other button, I get a 1. So if you like, the loop is running and it is picking up the presses on both buttons. Now what I'm going to do is just uncomment this line here. So all this is going to do is cause the right hand stepper motor to move 1000 steps. So what I want to be able to do, think about it from a project point of view, I want to have 2 buttons that could trigger this stepper motor at any time that I want. So let's quickly upload the code and see the results. So the code is running, and as you can see, I have the right hand stepper motor is turning here, but I want you to notice the serial monitor. If I press a button, nothing happens. If I hold my finger down, you can see I've got a 1 there eventually, but that is only appearing when the stepper motor gets to the end of its cycle. So going back to the code, you can see that I am reading the buttons. I am then serial printing the buttons out. Then I am sending this stepper to move 1,000 steps, and unfortunately this is blocking code. There is obviously some kind of delay that is used within the stepper library, and that means that while this stepper motor is running, I cannot read any inputs or outputs. And I'll be honest, for products, if you like, when you're doing a decent project, that is not acceptable. That will create a pretty bad project, because if you can imagine, if this was going to be running for 15 seconds, you could only press the button once every 15 seconds, and you've got to time it exactly. So if you had any other sensors running, none of it is going to work. And that is why for the rest of these lessons, the stepper library here is going out the window. Goodbye, stepper.h. Now, the problem with not using a stepper library is that it means that we have to control the stepper motor ourselves without someone very nicely writing all the functions for us. So that is what is now going to happen in this next sketch. So the connections are exactly as they were before. There's some other information in here that I'm going to skip for now. I'm going to take you straight down to the main loop, because I have put some control items in here. So basically at this point, I have commented out all of the main loop apart from these little bits at the bottom. It's a normal timer using current millis, and all this is going to do is flash the LED on or off at 1 second intervals. Also in the main loop, I'm checking if the left or the right button has been pressed, and if it has, I'm going to serial print out the value of the left and the right button to the serial monitor. So as you can see, the new sketch has uploaded, and looking at the project, you can see that the LED is now flashing on and off once a second. If I now press one of the buttons, look at the serial monitor, you can see the button is being read. Press the other button, that's being read. If I press both buttons, you can see both are being read. Now, the reason for this is to use these items as a control system, because if that LED stops flashing, or if I cannot read these buttons, then it means that the new code that I'm writing is blocking again. In other words, I've got a delay somewhere within my code. Now, going back to the top of the sketch, there's some information that we're going to use. Now, for this first example, I will only be using the left stepper motor, one stepper motor at a time. Right, let's have a look at how this is going to work. So on our component, let's just bring it up, the picture of the item. We have these pins, IN4 going down to IN1. And depending which pin is high, bizarrely, that makes this particular LED light up, depending which pin you're on. But that will also make the motor move to its next position. So I have created a very, very simple diagram for this. So here is my terrible diagram. And we've got those pins that I've left on the left hand side here, IN1, 2, 3 and 4. Let's imagine that IN1 goes high. That's going to be this pin here. It's 0, 1, 2, 3, 0, 1, 2, 3. So if this pin is high and the other pins are low, the motor will, if you like, turn until it is facing this position 0. If I now make IN2 high and the other pins low, the motor will now turn until it faces position 1. The same for position 2 and position 3. Now, obviously, in this diagram, there are only 4 steps. Within the stepper motor, there are actually 32. So it goes 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 to create a massive loop that consists of 32 items. But basically, it's moving one step at a time. And the stepper motor is always going to, if you like, try and jump to the magnet that has just gone high within the stepper motor. So whichever pin is high, that is where this stepper motor is going to face. So that means for our code, basically all we have to do is work through these steps one at a time. So going 0, 1, 2, 3, so making IN1 go high, 2, 3, 4, or if we want to go in the other direction, we need to go 4, 3, 2, 1. It's as simple as that, but although it sounds simple, obviously it requires some code to do that. Now, if you've been following this course and you've just done the lessons on servos, that will help you tremendously in this lesson, because once again, we're going to be using arrays and we're going to be timing, if you like, the steps between positions. So we're going to start off, obviously I've got 2 arrays. One is the left stepper motor pins, the other is the right stepper motor pins. Now obviously I'm only going to be using the left stepper for this example, but everything for the left stepper is duplicated for the right. So the left stepper motor is connected to pins 4, 5, 6 and 7. I've then got an integer here that is going to be used to keep track of which of these pins is currently set high, so that if you like, I can then track which position I am currently in. Moving down the sketch, we have a variable here, unsigned long, current micros. Now, those who followed these courses will know about current millis, where we are keeping track of the number of milliseconds since the board started. However, for steppers, we need far more accurate control, so we're going to be using current microseconds, which is the microseconds since the board started. But thankfully, the code that we have learned to use in milliseconds will work very nicely in this. So again, I've then got left stepper micros and obviously the right for the other stepper motor. Then I have got the timer, if you like. This is the time between steps. So this is 25,000 microseconds, which would be 25 millis. Now, you'll notice that the right stepper has a much smaller value. That's because I want the two to work at different speeds. One little warning about this: the lowest value that I have managed to make this work is 1760, which is 1.76 milliseconds. Now the reason for this is, if I bring up my image again, think about the motor. It's pulled to a position, then so many milliseconds later, or microseconds, it gets pulled to the next position. If the value between the steps is too small, the stepper motor physically won't have had time to move to the next position before the following position gets triggered, and at that point the stepper is going to, if you like, lock up, because it can get to the point where it finishes up going 0, and before it gets to 1 it could have even jumped to 3. It doesn't know which way round it's going anymore. So 1760 is the lowest I've got to, and realistically 1800 really is around the fastest that you want to use. Even so, don't forget these are microseconds, not milliseconds, so that is 2.5 milliseconds. So these are still moving very, very quickly. Now, just like with the servo system, we have the position that the stepper motor is in, and then we're going to have a target position that the stepper motor is moving towards. Once again, the rest of this is just to do with the buttons and the LED, and we've used this so many times I'm not going to bother explaining it. So let's have a look at the setup. So the setup, left button, right button and LED, not going into that. Then I've got a for loop. So I've defined a variable Q, and I'm going to go round this for loop 4 times from 0 to smaller than 4, because it is a 4-element array, 4, 5, 6 and 7. And all it's going to do is whiz through that array, and it's going to set pin 4, then pin 5, then pin 6, then pin 7 as outputs, because those are the pins that are going to control the stepper motor controller, the ULN2003. Coming down to the main loop, the first thing that I do is I take the current micros value, which is the number of microseconds since the board started. So this is exactly the same as using current millis, except obviously instead of a value in milliseconds, the value is now much smaller. It's in microseconds. Next bit of code. Has the stepper motor got to its target position? So if the current position is not equal to the target position, then the stepper motor needs to keep moving to get to its target position. So if that's true, then the next thing I'm checking is it time for the stepper to move? This is a normal timing circuit. We've used it many times before. The only difference is because it's using microseconds, it's going to be whizzing around much faster than normal, but that doesn't make any difference to the way that we write the code. Then all I'm doing is saying, right, is the current position smaller than the target? If it's smaller than the target, we need to increase the position that we are currently in. Obviously, if it's the opposite, then I need to decrease. They're never going to be equal, because this if statement only runs if the values are not equal. So it's got to be greater or smaller. Then it's this code that controls which step the stepper is making next. So what I'm going to do is quickly paste a line in here, and I'm going to paste in the declaration of the array. Now obviously I've commented it out because you can't have this line in twice. So we've got an array with 4 positions, and they have values of 4, 5, 6 and 7, which are the pin numbers. So what I'm saying is, if I need to increase in value, so going back to our diagram, we're going this way around the stepper. So we want to go 0, 1, 2, 3, which is our pins, 4, 5, 6 and 7. So if the current position is greater than 2, which means that right now we're at pin 3, then the next position needs to go back to 0. So if it's greater than 2, go back to 0. Otherwise, increase the current stepper position. So if we're in 0, then move to 1. If we're in 1, move to 2. And that's going to jump through which pin we then set high. Obviously, this is the opposite direction. And as such, it works the other way, in that if my stepper array position gets to 0, then it needs to jump back to 3, because obviously I'm looping round in the other direction. Apart from that, I just need to decrease the value by 1. So once I know what pin is got to be set high and which has got to be set low, it's literally a case of picking the pin out of the array, setting it high, and then working through a for loop of the 4 pins and saying go through that loop providing it's not the pin that I just set high. All the other pins, I want it set low. So that means going back to the top, I've set this one high, and then I've worked through all the pins, skipping this one and setting all the others low. And exactly the same here. This one would be set low, this one would be skipped, and then these two would be set low. So looking back at that final bit of code, at that point, the pins will have all been set. The loop continues, and once again, it will now wait. Does it need to take another step? Has the time in microseconds gone by? It will just keep racing round and round this. But at the same time, as it finishes this section, it will then read through this other code. So it will be checking, does the LED need to flash? Are some buttons being pressed? What else is going on? And then of course there's this little bit of code, which I'm not going to go into in a huge amount of detail, because all it's saying is if the left stepper position is now equal to the target position, give it a new target to aim towards. Usually this would be done by some kind of other input, a button or whatever, but just to make the code run, I'm just using this as an example that when it's got to the end of its movement, it's just going to go automatically to a new position. So the code is now uploaded. As you can see, it's now moving towards position 1000, but at the same time we can see that the LED is flashing as this stepper motor here is slowly rotating. Notice it's got to 0. It's now going to go back in the opposite direction. But if I press the buttons, you can see that on the serial monitor, these buttons are totally responsive, even though the stepper motor is moving. So we now have some stepper motor code that is running and is not blocking any other item. Now, the good news is that that is the most difficult part of today's lesson over with. So let's just do a quick recap. We are constantly looking to see, has our stepper motor reached its target position? If it hasn't, we're waiting until some time has passed, and then we are incrementing the stepper motor position to keep checking if it's got it to its target. But when we've done that, then we have to move the stepper, that individual step, which is done here and in this code here, where we are checking, do we need to go forwards or backwards, and in which case, which pin needs to be set high in here, and which pins need to be set low. Now, if you're still struggling, I'd advise you to go back through the code and have another look. And if you're really struggling, just drop me a line off the Digital Town website. There's an email address at the bottom of the lessons page. Make sure you let me know which sketch you're actually working on. And also, obviously, below the YouTube video, please feel free to put a comment in. And if necessary, I can even add some extra videos to try and explain the final details. Anyway, let's get on with the next sketch. So looking at the code in sketch 2, if you remember, when I got to the final position, I then just set a value, if you like, the alternate direction. I'm moving the stepper between 0 and 1000. However, pressing the buttons, you can see those values. I didn't put those buttons in for nothing. So what I'm now going to do for the next sketch, we are going to control the stepper, not with this little bit of code, but we're going to set its destination position using the buttons. This obviously is far closer to the way that it would work in a project. So stepper version 3, everything at the top remains the same. All of these items, all the variables remain the same. I'm still only going to be using the left-hand stepper motor. The beginnings of the buttons and the LED, all of this remains the same because this is just controlling the timing of the LED. However, I've added two more variables, button millis and button timer, because obviously I'm going to need to debounce the buttons. Now, I'm not going to go into any detail on debouncing the buttons because those have been covered in previous lessons. So coming down to the main loop, this was the bit of code that was used when the stepper reached its final position. One of the interesting bits with this new bit of code, it will run at any time. So if the stepper hasn't got to its final position, it will just give it a new position and it will change direction instantly. So this is the code. As before, current millis is declared, and this is initially being used for the LED timer. However, once we have current millis, we can also use it in a debounce situation. So I'm reading the left button, the right button, and if the left button is being pressed, I'm going to set the left step target to 1000, and I'm going to set button millis equal to current millis as a debounce so that it doesn't read multiple presses. The alternative, of course, is that the right button had been pressed, in which case, if that's been pressed, I'm going to set a target value of 0, and once again I'm going to reset the button millis for the debounce. So again, this code has been covered before, but the reason for doing this is, okay, we're using buttons here, but we could have been using sensors instead. So just remember, you can always replace the button code with sensor code, so that if a certain sensor is triggered, that would cause your stepper to move to whatever position you desire. So the code is now uploaded. LED is still flashing away. If I press this button here, we can see that the stepper motor starts to move. However, if I press this button, it'll immediately start moving to its new position. And once again, I can press the other button and set it back to the first position. And it will now just keep going until it reaches its, if you like, its destination position, at which point it won't have any other instructions and it's just going to stop. Of course, I did forget to work out how long that's going to take. There we go, it's made it. But as you can see through all of that, that other LED is still flashing away. It's not been blocked. And again, as the stepper moves back, that LED is still flashing. So our buttons, which could be sensors, are working nicely, as well as a separate output to the LED. I think that's a success. Now for the final sketch of today, I'm going to move both steppers together. The reason is the person who'd actually requested that I look into steppers is using a number of stepper motors at the same time, and obviously they need them to be moving simultaneously, but probably at different speeds and in different directions. So we're going to start to look at the beginnings of how that will work, but I will continue that in the next lesson. So in this particular sketch, this time obviously we're going to be using the right stepper, so we're going to be using the right stepper array position, the stepper pins, everything is in here already. It's basically a duplication of the left hand stepper motor, the way that that works. The big change is when we come down to the setup. Obviously I'm setting the left stepper pins, but at the same time I'm now adding in the right stepper pins, and if you had some other stepper motors, you'd actually duplicate them below here. Coming down to the main loop, this is the left stepper motor code, and I have literally copied and pasted it and replaced all of the lefts with right, because I'd created an identical set of variables. So this code is going to run as before for the left stepper motor. At the same time now, the right stepper motor is also going to work. Now, one of the things that is different between the two stepper motors is that the left stepper motor is waiting for 25 milliseconds, which is 25,000 microseconds, whereas the right-hand stepper motor is going to move every 2,500 microseconds, which is 2.5 milliseconds. So one stepper will be moving much faster than the other. Apart from that, it works in exactly the same way with the directions and everything else. And then the only other change that I have made is coming down to the button code. When the one left button is pressed, the left target is set to 1,000, whereas the right target is set to 0, and the opposite. When the left is set to 0, the right is set to 1,000. I'm not going to go into this sketch in great detail because the code here is exactly the same, and if you wanted to add more stepper motors in, you could repeat this code over and over. However, in the next lesson, I will explain how we can shrink this code down into some functions to make it usable by multiple steppers. So let's upload the code and see the results. So here we have our code uploaded. Now if I press the button, only the left-hand stepper starts to move, and that's because that has set a position of 0 for the right-hand stepper, but a position of 1,000 for the left stepper. Now, as this started at position 0, it's got nowhere to go. If I now press the other button, you'll notice they both immediately start to move in the other direction, but because the right-hand stepper is moving so much faster, it's reached its destination already while this other stepper is still, if you like, plodding away. Pressing the other direction, you can see again the difference in speed. And of course, while all this is working, our LED is still working independently. So at this point, if you are building a multiple stepper project, you can now have two steppers running in different directions at different speeds. I've got them controlled obviously off the same button, but you may have them controlled by different buttons or different sensors as you require. So quite a long and complicated lesson to get your head around today. If you've just got the one stepper motor, I would just work on that one for now and get your head around how it works. And again, as I've said before, any questions, stick them in the comments or email me off the Digital Town website, and I can either do some extra videos or get back to you on it as required. So I think that's it for today, and in the next lesson we'll look at how to try and simplify the code for future projects. So thanks for watching, and I'll see you in the next video. Bye for now.